Section 7.3, we're going to divide into two sections again. The first part of the section, we're going to talk about simplifying rational expressions. And there's two rules that you're going to have to kind of need to know about radical expressions. First one is the product rule, and the second one's the quotient rule. And they both should kind of make sense based on other things that we've talked about this year. But if I have two numbers that I'm multiplying, two radicals, but they have the same index right here, and that's key, they have to have the same index, then what you can do is you can multiply the radicands underneath together and put them underneath the same index. So you can kind of join those together. And the same can be said with quotients. If I'm dividing two radicals that have the same index, I can put them under one whole radical. And then, of course, the opposite is true. If I have one big radical, I can split it into two parts. Or if I have multiplying two numbers underneath a radical, that can be split as well. So why know these and how are they going to be used? Well, if we take a look at number 1, we have the cube root of 2 times the cube root of 32. If I try to take the cube root of 2, you'll notice there is no number. And if I try to take the cube root of 32, again, there isn't a number. But if I multiply them together, 2 times 32, that's going to give you the cube root of 64. Now, what you should know, if you've been kind of making those lists, is that the cube root of 64 is 4. So we can simplify those together and pull out that number. So what I want you to do, go ahead, do number 2, 3, and 4, pause the video, and then see how you do. Alright, in number 2, hopefully you brought them together, so when you multiply, that's going to be 18, and that's going to be x squared. Now if you take a look at this one, there really isn't a fourth root of 18 or a number that goes in, and you can't take 4 into 2, so this is a trick one. This is as simplified as it gets. In number 3, we should apply the square root to the 9, then to the 25, and then reduce, so it will be 3/5. Then for number 4, we're going to do the 5th root of 7 over the 5th root of 32x to the 5th. Now, you can't take the 5th root of 7, but you can take the 5th root of 32, which will be 2, and the 5th root of x to the 5th, remember, we're seeing how many times it can go in. It can go in 1, so it's x to the 1st. So that's going to be our answer for number 4. Another way to simplify radicals is to kind of break them down a little bit. We saw in the last examples that some of them broke down, some of them didn't. We had the 5th root of 7 versus the 5th root of 32. 32 was perfect, so we were able to break it down to 2. 7, though, couldn't be broken down. Now, if you look at square root of 18, it's a little bit different than either of those. 18 isn't a perfect square, but if you think about how 15 can be rewritten, it can be rewritten as 9 times 2. And if I split that apart, it can be written as square root of 9 times square root of 2. And square root of 9 is a perfect square. So I can make that into 3, but I can't do anything with the 2, so I leave that underneath the radical. And I'm left with 3 square root of 2. So in this case, it's really important to try to know those numbers and have those lists down in front of you so you know what the perfect squares and perfect cubes are. If I look at number 16, again, there's not a cube root of 16, but 16 can be written as 8 and 2. And I can take the cube root of 8, which is 2, but I can't take the cube root of 2, so that stays underneath. If you look at number 7 is square root of 14, so that's square root of 7, square root of 2. Neither one of them are perfect squares, so actually square root of 14 is as low as it goes. I'm actually going to skip number 8 and we're going to go to number 9. This is a little bit different with the variable. So our index is 2, and I can split that to be the square root of 81 and then the square root of y to the 5th. Now, square root of 81 is 9. That works out nicely for us. Now, with the square root of y to the 5th, we know there's 1, 2, 3, 4, 5, and the index is 2. So we're looking for the pairs. There's 1 pair, 2 pairs. So I'm taking out y to the 2nd. But you'll notice that there's 1 y remaining. That y goes back underneath the square root. You could also just divide it. 2 goes into 5 twice, 1 remaining. So let's do number 10. I'll do the cube root of 24 a little bit separately. So it's going to be the cube root of 8 times the cube root of 2. That's going to be 2 cube root of 2. 3 can go into 9 3 times. And 3 goes into b once with 1 left over. So now what we're going to do is we're going to put it together. And we're going to get 2a cubed b, sorry, that should have a cube on it, and the cube root of